All right, welcome to our chapter 18. This would be part 4. So I'm going to try to go a little bit quicker through the last couple problems here. I have a bunch of them written out, and we're just going to go through them at a relatively quicker pace because they're very similar to the previous videos. So number 12, we have research has shown that there are few known behavioral risk factors for breast cancer among women in the U.S. despite numerous studies investigating the outcome. One such risk factor has been studied. Partly or number of pregnancies experienced by a mother over the course of her lifetime has been determined to have a protective effect against the disease. In order to test this finding, researchers obtained medical records from a major cancer institute and recruited a group of women with breast cancer frequently matched to a group of cancer-free controls attending the hospital with another non-fatal illness. The exposure of history and number of pregnancies recorded for each patient. The following table represents the preliminary analysis of the result. So as you can see, when you have a group of women with breast cancer matched frequently to a cancer-free controls, so you have a case to a control, and this is a case control study. Next, we're going to be looking at Part B. Part B, so let's go to the table actually first real quick. So you have your breast cancer, your disease on top. So you have breast cancer, no breast cancer, then no children, 1 to 3 children, and more than 3 children. So Part B says conduct a formal hypothesis test to determine if there's a relationship between the various levels of exposure and the outcome. Write out your null alternative hypothesis and interpret your results at an alpha level 0.05. So we're going to be doing a chi-square test. So our chi-square null hypothesis is going to state there's no association between the variables. Alternative hypothesis is going to state that there is an association between the variables. Here we have our expected values. So up here's our observed values, and you have our expected values here. Remember, the way you get your expected values is you're going to take your row total times your column total over the table total. When you do that, you'll end up with this table here that matches to above, where you have breast cancer, no kids, 1 to 3 kids, and greater than 3 kids. Plug it into your chi-squared formula. Chi-squared formula, once again, is going to equal the sum sigma of all of your observed minus expected values squared divided by your expected values. So you can see that the work being done out here, these are the values you get per each of the equation above. When you sum them all up, you're going to get the chi-squared value of 199.5425. When you go to the back of the book, you're going to go to your table E, your degrees of freedom. Remember, degrees of freedom is equal to rows minus 1 times your columns minus 1. So when you have rows, you have 3 rows. Minus 1 is 2. Columns is 2 minus 1, which is 1. 2 times 1 equals 2. So your degrees of freedom 2, alpha level 0.05. And you'll see that your value is 5.99 as your critical value. 5.99 at alpha level 0.09. Our chi-square value is greater than 5.99, so we reject the null hypothesis there. Our actual p-value is quite lower. If you were to keep going, you'll see that it's going to be less than 0.005 according to the book. So you could say p-value is less than 0.0005. Actual p-value, p equals 4.676 times 10 to the negative 6, I believe. And that is, so we reject null hypothesis, basically stating that there is an association between the variables. Next, we're going to calculate the appropriate risk measure between the categories of exposure and things. Since we have case control, we're going to be using an odds ratio. When you do an odds ratio, you're going to be using no children as your control group, so that's going to be your AB variable. So when you plug in your AB variables to children 1, 3, and then no children to greater than 3 children, you'll see that no children to 1, 3 children have a higher risk associated with them compared to having children. If you actually did another one where you did just 1 to 3 and greater than 3, you'll have an even smaller risk factor. And from this, you can extrapolate that having no children is an increased risk of having breast cancer. Moving on to number 3. Here we have research of Alzheimer's and sleep apnea. I'm not going to go through reading all of it. You can all read now on your own. I'm going to get to calculating the prevalence of sleep apnea and participation groups. So here we have our prevalence. Remember, so we're going to have our prevalence is going to equal to A over the N. It's the total, A of 1. So it's whatever area we're looking at. So for this one, we're looking at the prevalence of sleep apnea in the participation population, right? So we're looking at sleep apnea. When you have sleep apnea, this entire column here is all sleep apnea individuals. So when we want to calculate the prevalence of sleep apnea in the population, we find our total. So this is going to be your 208 over 468, and that is going to equal 0.4444. Next, we want to calculate the prevalence of early onset senile dementia based on the curriculum established by the research team. So we're looking at senile dementia, early onset of it. And so here we have early onset dementia. We're not looking at it based off of sleep apnea or no sleep apnea. We're looking at the total. So we're going to do 126 over the total of 468, which is going to give you 0.2692. Next, we want to carry out the formal test of significance to determine if there's a difference on the onset of senile dementia. So once again, you're going to get your chi-squared. Doesn't state to do a hypothesis statement here, but we know that a hypothesis statement will state that there is no difference as our null, and there is a difference for alternative. Chi-square equation, here's your expected value table. Plugged into the formula here, sum it all up, and you're getting a value of 2.8151 as your chi-squared value. When you go to the back of the book, we're using degrees of freedom 1. When you go to the back of the book, degrees of freedom 1 at an alpha level 0.05, shown here. Remember, if the alpha level is never given, it's always to assume that's 0.05. So at 0.05 at alpha degrees of freedom 1, we have 3.84 critical value. Our value is less than that. We have 2.8151. So based off an alpha level of 5, we would fail to reject the null hypothesis. So our p-value is going to be greater than 0.05. We don't know the true one. If you were to go down the next one, if you looked at alpha level of 0.10, it's 271. So at 0.1 alpha level, our crit would be 2.71, and we see that our value is greater than 2.71, so our p-value is going to be less than 0.10. So we know our actual p-value is going to fall actually between those values. If we stated a null hypothesis, we would fail to reject at alpha level 0.5, but we would reject at alpha level 0.10. Actual p-value here is 0.0934, which makes sense because our probability is going to be between 0.10 and 0.05. Next, we're asked to calculate the odds ratio for early onset senile dementia due to sleep apnea. Do A times D over B times C, you get an odds ratio of 1.4194, which is stating that if you have sleep apnea, you are 1.4194 times let me start over. If you have sleep apnea, you're 1.4 times more likely to have onset early senile dementia than if you don't have sleep apnea. Last part here, we're calculating the 95% confidence interval for the odds ratio. So our odds ratio we calculated is 1.4194. You take the ln OR, once again, you find ln in your calculator, type ln, enter in 1.4194. It'll give you the ln of the OR, which is 0.3502. Our z value, z of 1 minus alpha over here is going to be 1.96. And our standard error is going to be 1 over a plus 1 over b plus 1 over c plus 1 over d, square root of all of that. When you put all that in the calculator, 0.2092. Remember, parentheses, if you're putting it all in your calculator, have to make sure the parentheses are right to do it all in one setting. To carry out the rest of the equation, we're going to have our e to the 0.3502 plus or minus 1.96 times 0.2092. You work this out, you're going to get e to the negative 0.0598, comma 0.7602. Remember to use your e squared function. So E squared to each of these values separately, and you're going to get a 0.942 to 2.1387, and that is your 95% confidence interval, stating that we are 95% confident that the true odds ratio lies between this interval. Just have a little bit of time left. So once again, here we have our study here. Once again, I'm not going to read it all, but if you do look, we're going to be following patients over a period of time. And when you follow them, here it is, follow them over for a 1-year period. So we know this is going to be a cohort study design. Next part is conduct a formal test to determine if there is a significant difference in the outcome between the variables of the ratio group throughout your null and alternative hypothesis. So once again, our null hypothesis states that there's no association between the variables. Our alternative hypothesis states that the association does exist between the variables. Here we have our expected value table, and here's the chi-squared formula worked out, and you're going to get a chi-square that's going to equal a sum of 26.09. We're at alpha level of 0.05 here, and our degrees of freedom 3. We have a critical value of 7.81. Our chi-square is greater than the critical value, therefore we reject the null hypothesis, stating that there is an association between the variables. Last part here is calculate the post risk measurement for each racial group of using the Caucasian category as the reference group. So once again, if you're using a cohort, we're going to be wanting doing relative risk. So here's the relative risk using Caucasians as the control group. So this is Caucasians to African Americans, then Caucasians to Asians, and then Caucasians to Hispanics. And here is your relative risk for each of the groups. So as you can see, the highest risk factor, highest risk group comparison is Caucasians to Asian Americans. I'm not going to have time to get